All right, so this week we are going to finish up, we're going to start and finish chapter 5. We only do 1.5 sections in it. And it's our last real type of function that we study before we do trig. So there's still other couple things before we do trig, but they're not new types of functions. So we've studied polynomials, we've done quadratics, we've done square roots. Now we're going to do log functions. So first, let me show you something first, and then I'll show you what I was going to show you. If I asked you to solve that one, it's a little bit different kind of equation because the variable is in the exponent. What power could you raise 2 to get 8? Yeah, that one's not bad because 8 is a power of 2. Now, if I get something like this, 2 to the x equals 7, I didn't change much. All I did was change the number on the other side. But 2 to the third power is 8. That's too big. What's 2 to the second power? 4. Now we're trying to get 7. 2 to the second is too small. So the way we would figure out what that number is to use a log. That's what logs do. So they basically figure out an exponent that you don't know. That's what a log is. A logarithm is an exponent. And I'm going to say that again. Connecting this to what we did in 5.1, we studied exponential, like exponential growth, exponential decay. These functions are the inverse. So when you talk about, another example is like taking a square root and squaring. Square root and squaring are opposites, right? They're inverses of each other. Same with these two. Logs and exponentials are opposites of each other. They're inverses. Right, so that's the connection to what we studied before. They're inverses. I want to show you visually. In red, that is what a log function looks like. In blue, that's what an exponential function looks like. Can everyone see how if you folded it right on that black line, the blue one would land right on top of the red one? You see that? So when I say that they are inverses of each other, that's what inverses means. They have a kind of like a mirror image of each other.
You scroll back up to the text above.
Yep. So they're inverses of exponential functions. Okay, we're not going to do a lot with graphing logarithms today. We'll see if we do a little with that tomorrow. All right, so first thing is when you see a log, how do you write it and how do you pronounce it? So let's say you had lined paper like that. That is how you would write it. Okay, the y, the equals, the log, and the x are right on the line. The a is below the line. Okay, it's a subscript. It's written a little bit below. And the way that you read that is y equals log base a.
Base A just means it's lower than log.
Yep, so that's called your base. Explain what that is in a minute. So y equals log base a of x. The x, that is called the argument. All the argument means is it's the thing that you are plugging into the log. So kind of like if I did a square root and I wrote square root of 8. 8 is called the argument. It's just the thing that I'm taking the square root of. Now, what's the base do? Well, the base is just there to tell you what kind of log they want you to do. When I write that, what kind of root does that mean?
Square root.
That means square root. when I write that,
Cube root?
that's a cube root. This little number just tells me the kind of root that they want me to do. That's exactly what this number does right here. It tells me the kind of log that they want me to do.
So what's an A log?
What's that?
So if A tells what the log would be.
So the A would have to be a number.
Oh.
Yeah.
It could be like,
The A, so it could be like log base 3 of 7. So if I wrote something like this, that means they want you to take the log of 7, but the type of log they want you to do is a base 3 log. And there's a way to type that in on the calculator. Okay. If I wrote log base 4 of 7, that still means to take the log of 7. It's just a different kind of log. It's a base 4 log. Just like a cube root versus a square root. They're both roots, just a different kind of root. So any question on, first, just how you write it? So when you write something like, I just put a box around, there's no exponents there. An exponent would be like up there. That's an exponent. Okay. The log and the 7 would be right on the line, and the 3 would be below.
so the argument can be an exponent?
You,
A number with an exponent?
you could have an exponent, sure. Now the argument is 7 to the 5th power. Yep. But now the argument is just 7. There are two kinds of bases that come up most often. Base 3, base 4, those are not common. Those are, we don't use a lot. One that we do use a lot is base 10. Base 10 means common log. So anytime you write something like log base 10 of 24, you're taking the log of 24, and the type of log that you're doing is base 10. Another way to read this is the common log of 24. There are two logarithms that have special names. One of them has a base of 10. I'll tell you the other one in a second. Other than those two, there are no special names. Okay? Like log base 3 doesn't have a special name.
But log base 10 is just common.
Log base 10 is known as the common log. Yep. And it's one of the two bases your calculator can do.
So if they're like, find the common log, you know it's base 10?
Base 10.
Or they won't say that?
No, they would, yeah, they could say it like that. Yep. There's two buttons on your calculator for logs. They're both on the left-hand side near the 7 and the 4. The one right next to the 7 that I'm circling right there, that's the common log button. Okay? That one is called, that is base 10. The calculator can only do 2 logs by pressing a single button. If you wanted to do something other than those two, we got to learn something else. Okay? But we're just going to focus on those two for today. Now, because the common log is used quite a bit, you do not have to write it like that. You could just write this. What's on the left and what's on the right means exactly the same thing. So if you ever see a log written and there is no base to it, the base is always a 10. If they don't want the base to be a 10, then they need to write what it is. Like I did up above, like base 3, base 4. All right. So any question on the idea of what it means for something to be a common log? Yeah.
So, what is 10 the only common log?
Yes, yeah. If it's not a 10, it's not called a common log. Yeah. If it's base 9, that's just called base 9. There's no special name for it. And if you want to type in a common log on the calculator, like let's say you want to know what the log of 24 is, all you do is press log 24 and you hit enter. Now when I hit enter, I get that number. Let me bring that back up. 1.3802, and it keeps going. What is that number? Well, that number is an exponent. Let me show you where it's an exponent. What's the base on that log? That's 10. If I raise 10 to a certain power, I can get 24. Right? Well, if I raise 10 to the first power, what do I get? 10. No, too small. Let's try 10 to the second power. That's 100. That's too big. Let's try 10 to the 1.3802 power. Take 10, raise it to the 1.3802. Look what I get. I get basically 24. So anytime you press log, then you hit enter and you get an answer. That answer that you get is an exponent on something. Okay? So that's what a logarithm is. A logarithm is an exponent.
And it'll ask us for like the first two decimal places or something, or what?
Yeah, anywhere between 2, 3, sometimes they do 4, but yeah, it's like 2 to 4 decimal places. Yep. All right. Any question on that idea? A logarithm is an exponent. That's important to remember. Logarithms are exponents. That's what they are. Okay, so that's one special type of log. The other special type of log has a certain number for the base, a number you're probably not as familiar with. It's e. Okay, so just like in math, we have a Greek letter pi. Stands for 3.14. Well, e is the number 2.718, roughly. It's another special number in math like pi. Not used as much as pi, but it's a special number used for some things.
You did second, the divide symbol?
Yeah, that's how you can get to the e. It's the second divided by symbol. It's a number that's built into your calculator, just like pi. And if you do a logarithm where the base is an e, that is called the natural log. That is the only other logarithm that has a special name. So you have common log, which is base 10, and you have natural log, which is base e. Now, when you have something that is base e, just like when you have something that's base 10, they like to shorten it. Now, could we shorten it by just not writing the e and doing something like that?
No, because that would be log 10.
That would be common log. So you can't just not write the base. If you don't do that, it's base 10. But what you can do is use those two letters as an abbreviation. LN. Well, I don't know why they don't do NL, but they use LN. So whenever you have a natural log, if you want to write it shorter than that, you can write LN.
Is that what that button below log is?
Yep.
Gotcha.
So LN is 2 letters. Log base E is 4 letters. So tap with one. So an example with like a number, you probably will never see this on a test or in the book. You won't see something written with base E. They're going to take all of that and they're going to change it to those 2 letters. That's what you would see written. The thing that you have to remember is when you write LN, there is still a base there, but it's hidden, right? It's just like a common log, it's hidden. The base on LN is E, but you don't write it. You just write exactly what I circled right there. And that is the other log that your calculator can do automatically.
Will we be allowed, like, I know there's like, I was watching a video, we would be able to use a calculator, right? Or
Yeah.
are we going to do anything without the calculator?
We'll do some things without it, but you wouldn't be able to do that without it.
Okay.
So if you wanted to know the natural log of 8, You hit the natural log button, and you get 8. And that's the answer. And remember, that's a logarithm, so what is this number right here? It's an exponent. We don't have to worry what it's an exponent on, but it's an exponent on something. When we're solving a problem, we would know what it's an exponent on. Okay, so any question on that name, natural log? Okay. So let me put a log on the calculator so you can see what it looks like.
I don't know what X is.
Actually, I had a better one. Where was it? Right there. Look at that one in red. That's what a log function looks like. The calculator doesn't do a good job, especially in this area here, because it starts to get very steep. Okay, and remember, when something gets steep on the calculator, it just kind of gives up. So what you're going to see on the calculator is something like that. That graph in blue it's not right. Where does it look like it stops? Looks like it stops at -1. But if I zoom in, watch what happens. Does it look like it goes below -1 now?
Mm-hmm.
Yeah, the calculator doesn't really know how to draw that. Right? It does go down forever. So it goes down forever, and it does keep going up forever. Okay? It goes up extremely slowly, okay? But it does go up forever. So if it goes down forever and up forever, what do you think the range is?
Negative infinity, common infinity.
Yes, the range is all real numbers. In fact, it probably goes up even slower than the way I drew it. It almost looks flat. It's very, very slow. Yeah.
Is that for all logs they do that?
Yeah, all log functions generally look something like that, unless you were to take it and like flip it over. Then it could look like it goes the other way.
So if it asks us for the range of a log, it's going to be usually all real numbers.
It's always all real numbers.
Always all real
Yep. How about the domain? Does it look like the graph in red goes left and right forever?
Yes. No.
No. Which direction does it go in forever?
Right.
Yeah, it does keep going to the right. Right? That's going to keep going. But going to the left, it stops at a certain number.
That's a 0.
Yeah, it stops at 0, and that's because there's one of those there. Anybody remember what we call that?
A dotted line.
We represent it as a dotted line, yep. What do we call something that a graph gets very close to but never reaches? An asymptote, yep. That's an asymptote. So it never really reaches that dotted line. It just keeps getting closer and closer and closer the further down you go. But that's the domain. It's every number, not including 0, but it goes to the right. So that's 0 to infinity. Okay, so that's the domain from 0 to infinity. What does it mean that I put a parenthesis on the 0?
It does not include.
It does not include it, right. Let's see what happens if you try to include it. So try to take the log of 0, and it says it's an error. It's not in the domain. You're not supposed to include 0 in the domain. That's why it's a parenthesis. Now, what other kind of numbers are not included in the domain?
Infinity.
Well, it goes to infinity, but what other kind of numbers are not in 0 to infinity?
Negatives.
Negatives. If you try to take the log of a negative number, a little bit different error. Doesn't say that it can't do it. It just says it would be imaginary, non-real. We're not going to be looking at imaginaries. Okay? So you have to stick between 0 and infinity for your domain. Any question on those two? Okay. So earlier on, I gave you a question, yeah, this one. 10 to the x equals 24. And somehow I figured out that x was 1.38.
And it's because log, you did log 10.
Right, I changed it. This is what we call exponential form. The reason it's exponential is because it has an exponent. When we write something with the word log, we call that log form. So what we have to learn is how do you change something that's exponential to log, or the other way, log to exponential. Yeah.
So in that calculator window you got there, is that like, where's the 10 fit in there?
The 10, it's an invisible base on the word log.
Oh.
Yeah.
How do you put that in the calculator?
We just press the log button. It's right next to the 7,
Okay.
to the left of the 7. Okay, so how do we convert between exponential form and log form? Well, let me show you what each one of them looks like first. This is exponential. It looks something like that. You have a base, you have an exponent, and then you have a number on the other side, like 2 to the x equals 5. Log form looks something like this. Log, you have a number that's lower. What do we call that number?
That's the base.
That's the base. And we have a number right there. What do we call that one?
The argument.
The argument. And then you have a number on the other side. So on the left is exponential, on the right is log. In each form, there's 3 things. Box 1, 2, and 3. To convert between the two, it's just a matter of figuring out where each box moves to. But what's in the boxes is going to stay the same. They're just going to move to different spots.
Wait, what's the number on the other side before the equal sign for log? Like, I don't remember the big number there. What was like,
Well, it'll be like, it could be anything. It depends on the problem.
okay.
It'll generally be like a letter or a number. We're going to do it with a letter right now. Yeah. Okay, so I'm going to show you a formula. In this formula, there will be a letter. There'll be a couple letters in it. But the letter A has to be greater than 0 and not equal to 1. I'll never give you a problem where you have to worry about that anyway. So let's start with that. What I wrote on the left there, is that log form or exponential?
Log.
Yeah, because it has the word log. When we write it in exponential, it's going to look like this. We just have to figure out where the y, the a, and the x are going to move to.
Well, you're still solving for y, so we're gonna need the y still. Interesting.
Okay, so let's look at it one step at a time and see kind of what goes where. Let's start with this one. What do you call that number that's a little bit lower?
Your base.
The base. When you rewrite something as an exponential, what do you call the number that's below the exponent? It's still called the base. So the base stays as the base. Next thing, logarithm always equals, and this is what I said a couple times, logarithm always equals what kind of number?
Any number that's not negative.
So like when you press log on your calculator and you get that number that comes up, that log, that is an exponent, right? So logs are exponents. Logarithms always equal some type of exponent. That's why the y becomes the exponent. And what did we call that right there? The argument. And if you argue with somebody all the time, you're going to end up by yourself on one side of the equation. So if you argue with someone, you end up by yourself. So that's how you can remember that one. So the base stays as the base. Logarithm always equals some kind of exponent. And the argument ends up alone. And that's it. It's just a pattern of moving things around.
Are we ever gonna have anything where we like have to write out the log by hand, or can we always use a calculator for that?
You won't need a calculator for like any of this, but some things you'll have to use a calculator for. Like this one, there's nothing you could do on a calculator because there's two variables. So the question is just to change to exponential.
Okay, but like for the test, are you gonna like,
There'll be some like this.
are there gonna be something we have to solve?
Yes.
And we can use a calculator for those?
Yeah, as long as you know how to type it in. Yep.
Okay.
Okay, so let's just start by identifying the three things. What's the 3?
The base.
So that's going to become the base. Logarithm always equals what kind of number? Exponent. So logarithm always equals some kind of exponent. And what do we call the thing that ends up by itself?
Argument.
Argument. And where is the argument up here?
X.
It's in the red box. And for that problem, there is nothing else to solve because you don't know what y is. Like if you knew y was 2, then you could do 3 to the second power and get 9 as the final answer. But we did what they wanted. Okay. Any question on that one?
Do you have more examples of this?
Yeah, I've got 2 or 3 changing to exponential, and then I got 2 or 3 changing to log. Yep. All right, let's try that one. So when you're done, you want to have something like this. In fact, we can put our answer right here if you want. So on the left is log form, on the right is exponential. Let's start with this box. What is that called because it's lower than the exponent?
Base.
It's the base. So look at your log, and now find the base on your log.
5.
5. Remember, if this was lined paper, it would look something like that. Okay, so the base is 5. Logarithm always equals what kind of number?
Y.
So y, and y is the,
Exponent.
yep, always equals an exponent. And the thing that ends up by itself is the,
Argument. 'Cause
Argument?
It's left out.
yeah, because it argues with everybody and doesn't want to be around. So now the argument is by itself. What's your argument there?
X.
X. Okay, and again, just to be clear, there's no exponents there in this part. To have an exponent, you would need something like that. Now the 8 is an exponent. Now there's no exponents.
So if you did have an 8 as the exponent on x, would it just carry over like regular?
Then it would just be x to the 8th power.
Okay.
Yep. Any question on that one? Okay. Let's try the other way. So now we're going to take something that's exponential and change it to log. Well, if you're going to change it to log, what's the first thing you think you need to write down?
You need to write down the equation, which is y equals log base a x.
Yeah, so the first thing I would just write down is just the word log. Without the word log, you don't have a log. So now we need a base, an argument, and an exponent. Okay. Start with the base.
Is it 1.2?
The base is 1.2 because that was the base on the other side. So 1.2. Logarithm always equals what kind of number?
Exponent.
Always equals an exponent. So now look for your exponent.
3.
3. And what do we call that?
Argument.
That's the argument.
So it's
And that's what was by itself. Okay. Any question on that one? I think I got one more of those. Let's try this one. E to the b equals 9. Okay, same directions. Change to log form. All right. What's the first thing you should put down?
log.
Log.
Would it be log
So what's my base?
E?
E. We're going to come back to that in a minute. We talked about log base E, but for now that's fine. Log base E.
Would it equal b?
It would equal the exponent.
And
Yep.
then 9 is by itself.
And 9 is by itself, so that becomes what you're taking the log of. So you're taking the log of 9, and you're doing it with a base of e. What is the abbreviation for that part?
LN.
ln. Yep. That would be the shortest way you could write that one.
Why is it?
And that's something you could type in on the calculator. That button is right below log.
Can we do another one of those?
So, let's just get rid of that. So if they wanted the decimal for this one, which they don't, it would be about 2.197.
But why is it like different? Why is it LN?
That's the abbreviation for the natural logarithm. Anytime it's a base of e.
Okay, so would it just be like, if it's just an E here, can we put any exponent on it? Like if it was x to the b equals 9, can we put a log x, and that still be the same as ln?
No, if it's x, it can only be an ln if that's an e.
What's the difference? Like,
E is the number 2.718. It's a very
okay,
specific
okay.
number. Yeah. Yeah, I have one more. We can do that one. Like this one is not E, it's A. But that A is just a random letter. We don't know what it is. But E we know is 2.718. Okay, change to log form. First thing I would write down.
Log.
Log.
Log A.
And the next thing is my base, which
A.
my base is A.
It equals 4 and then 24 is by itself.
Logarithm always equals your exponent.
look at you, Sean.
And now that one, there's nothing you can really solve because we don't know what the base is on the log, so we're just leaving it like that. We're going to do one you can solve.
I don't like the sound of that.
Me either.
All right, any question on that?
No.
Okay, so that's changing between log and exponential form. On the right is log form, on the left is exponential. All right, let's try this one. They're asking us to show that log base 2 of 8 equals 3. Well, there's only one thing we know how to do with an equation that's in log form right now. What's the only thing I've shown you how to do?
Change it to
Change it.
So let's change it to exponential. Nope, I haven't even shown you how to type that in on a calculator. It's only 2 bases we know how to type in. What are the 2 bases we know how to type in?
10 and E.
10 and E. Is that a 10 or an E for the base?
No.
Nope, then I haven't shown you how to type that in yet. Okay, so let's change it to exponential.
Would
What
it be 2 to the third?
2 is my base. Logarithm always equals the exponent.
It equals 8.
And what ends up by itself is the argument. And what's 2 to the third?
8.
8 equals 8. So yeah, we showed that that is true. And the way you show it's true is you get the same thing on the left and on the right. Any question on changing that to exponential form? Now, if it said log base 2 of 8 equals 9, that would be wrong. Because when you get down to this step, we'd have 8 equals 9. That's not true.
Can you keep that up one more second?
We'll do another one like that in a second.
You're good.
Okay. So now this one is to evaluate, to figure out what x is. So when you're done, you're going to have x equals, and then I want a number. Looking for a number. Okay. What format is that equation in?
Log.
Log form. So let's change it to exponential. What is my base?
5.
5.
To x.
Exponent is going to be an x.
Equals 1 over 25.
Equals 1 over 25. All right, now let's look at something a little different, because if you're confused with the fraction, let's look at something without a fraction. This isn't the same problem, but it's similar. Let's say it was 5 to the x equals 25. What power would you raise 5 to get 25?
Well, two.
Two. Right? This would be a 2. Now, this one we don't want to get 25, we want to flip 25. Does anybody remember what kind of exponent you need that causes it to flip?
Negative.
A negative, yes. So what would this one be? -2. Yep. So anytime that you want to get the answer, but you want it flipped, to flip it, just make a negative. So like if I had, let's say, 2 to the x equals 1/8. Okay, if you get stuck,
-3.
think of it like this first. Then once you get that answer, make it negative. So what would x be right there?
-3.
Right, the negative would cause it to flip, and the 3 would make it an 8. Yep.
So what's the rule for that? Anytime it's a fraction.
If you're trying to get a fraction, you want your number to flip, you need your exponent to be a negative.
Let's just keep it at that.
Keep it at that.
Yeah. Are we almost done?
It doesn't get too much worse. There's just a few more properties, but they're all about the same difficulty as this.
Okay. Sweet.
And they're not properties you have to memorize, because again, you can use your reference sheet or calculate, you can use whatever you need on the test. All right. Let's try this one. So start by looking at your equation. What format is that one in? Log. So let's change it to exponential. Okay. What is my base?
5.
5.
So 1.5
Logarithm always equals your exponent,
equals x.
and the argument ends up by itself. And that's it. That's your answer. So now if they wanted that, you just, here you do need a calculator. Right, 5 raised to the 1.5. It's about 11.18. They don't ask for a decimal, I would just leave it like that though.
I hate having math at the end of the day. I'm so tired.
You okay with that one though?
Yeah.
That's okay?
That was a little complex, but yes.
Okay. So that time the variable was the argument. Let's try it when the variable is the base.
So if we get like a question on the test that has a exponent that's a decimal, and it doesn't say like to the nearest hundredth or whatever, do you want us to just leave it?
I just leave it. Yep, just leave it. Unless it specifically says round your answer to 2 decimal places, you don't need to do it. All right, so another equation in log form. Yeah. Yeah.
Is x to the second equals 3?
Yeah, so x is your base. Logarithm always equals the exponent. Argument ends up by itself.
Where did the x go? Or sorry, where's the log one?
When you change from log form to exponential form, the word log goes away. That's the whole point, to get rid of the word log.
Wasn't the same as knapsack.
Now, what about, I got a power of 2. We talked about that last week. What cancels out squaring?
Rooting.
Square rooting. Yep. So take the square root. Take the square root.
X equals square root.
Square and square root, what happens?
Cancels.
They
So it should be
cancel.
x squared.
And we can just leave it unless they specifically say they want it rounded off. Any questions on how to type a square root on the calculator? Nope. Okay, so what's that one? Any question on how we got the square root of 3?
No.
All right, so second to last thing, okay, special properties of logs. These are properties that don't really involve any math. It's more of if you see a special pattern, you'll automatically know the answer without having to do anything out. All right, let me show you what I mean. Let's start with this first property. An example with numbers would be something, I'm just making these numbers up. 3, log base 3 of 5. When you have a problem like that, and this number matches that number, what ends up happening is because they match, these basically just cancel out. And the only thing you're left with is whatever is right there becomes your final answer.
That equals 5. No, I did not get that. So, a to the log.
Yep, a to the log base a of x. It's a very special pattern where these two numbers match. If you see a problem where those two numbers match, then all of that cancels. And whatever you're left with right there becomes your answer.
Okay, so just x equals 5 in that one?
In this one, yeah, the answer would just be 5.
What does that equation say? I think I'm just confused by the equation.
So it's a pattern when, here's another example, log base 4 of 13. It's a special pattern that comes up when these two things match.
That's the exponential. What type of form would that be though? Because that's not exponential.
That is exponential, yeah.
But it has a log in it.
There is a log in the exponent, yep.
But if there's an exponent, then it's any.
Think of it like this. Pretend like you can't see what's in those.
Oh, okay.
See the 3 boxes now?
Gotcha.
That's exponential format. Doesn't matter what you put under those boxes. Anything that looks like that is exponential.
Is it too early to drop out?
Yes.
Wait.
We can't drop out,
Well,
there's nowhere
it's
to
too late.
drop out
You
to.
can go back to algebra 2
I'm
though.
confused.
Really?
Would question mark be 3?
Not.
5. Okay, let's look at the
Give
top
me
one.
an easy
You
class.
would still have to take an extra.
What happens, because this 4 and this 4 match, what cancels out?
They cancel out and x equals 13.
Right, everything there cancels out, and all you're left with is that number. It's kind of like if I said to somebody and they didn't understand squaring and square rooting, and I just said, anytime you see a little 2 up high, and then you see that symbol on the outside, you can just cross them out, even if they didn't understand why. I just explain it that way. Right? You can cancel those out because they undo each other. That's what's happening right there. They undo each other. How about 5 to the log base 5 of, I don't know, 9?
It'd equal 9.
It would equal 9. And the reason why? These two things basically just undo each other, like squaring and square rooting. But they have to be the same number to cancel out.
Can't be 3.
No, can't be like 3 and then log base 4.
Are you going to show us what to do if they are different numbers?
No.
It won't apply to us.
No.
You
No.
don't need to know that.
No.
That's the best news I've heard all day.
Okay, here's another one. Now, let me cover everything for a second and don't look at what they are really, just focus on the boxes. Is that log form or exponential form?
Log.
Log, because it says log.
Log,
Okay.
because it says log.
But it has an exponent.
But it has
But look
log.
at, but it has an.
No, there's no, an exponent would be up here like that.
The base to the exponent. Okay.
Yeah.
Oh.
So remember, when you're writing this, right? Think of it. There's your paper. There's no. When I put the 3 boxes the way I had them, there was no exponent. That is log form.
But
Because
that's an exponential.
that's log form. If you see the word log, it's log form.
What?
If there says no log,
But that has an exponent in it though.
Right. To be log form, you need the word log, and that has the word log.
If it didn't, then yes, it would.
If you see the word log, it's log.
But
It's
you
not.
said up there it's not. On number 1 you said that's not.
That is log form, and I'm leaving it at that.
Because there's an exponent that has log in it.
That's a different. Yes, number 1 is different. That's
That one.
number 1 is exponential.
So if log's on the ground, then it's fine. But if
Yes.
log is up in the.
Yeah, if it's in the
air.
exponent, then it's exponential.
Okay.
So if you had like log
That was confusing.
base 4 of 4 to the x, it's kind of like the one we just did up above. When these two numbers match, everything cancels out. They undo each other, except for whatever is right there. That's all that's left. So in this case,
It'd be X.
the answer would just be x. We don't know what x is, but whatever x is, that's the answer. How about log base 7 of 7 to the 5th power?
It equals 5.
It would equal 5. These two things cancel out. Kind of like squaring and square rooting, they cancel out. And the only thing that's left is what's right there. So again, it's just a special pattern.
For that one that says log base 4x equals x, is that x equals x?
The answer is just x. We don't know what x is because they didn't give it to us. The answer is whatever is right there. All right, third one. Log base a of a equals 1. So that would be like log base 5 of 5.
Would it just be 1?
It would be 1. Anytime those two numbers match,
They cancel.
the answer is always a 1. How about log base 6 of 6?
1.
1. Yeah, it's 1. As long as these two numbers match. Basically, this is saying, if you wanted to think of it a different way, 6 to what power would give you 6?
To the first power.
To the first power. The top one is saying 5 to what power would give you 5?
The first.
The first power, yeah. That's all that this property is saying. How about log base 7 of 7?
1.
1. That's basically saying 7 to what power would give you 7? 7 to the first power. If you wanted to think about it and you weren't sure, like let's say log base 8 of 8, and you had no idea what it is, just put equals x. Which box there is my base?
Red one.
8.
The red one. Which box there is my exponent?
X.
X. And which box is my argument?
8.
The blue one. That's what that means. 8 to what power would give you 8? It's always 1.
1.
If these two numbers match. And that's all we're looking at.
It's just a quick way to do it.
Yes. These are all just quick patterns that if you see them, you automatically would know the answer. And the last one. This one says that if you take the log of 1, it doesn't matter what the base is, the answer is always 0. Oh, let's see why. Let's say you wanted to do log base 10 of 1, and you didn't know what it is. Okay. What's my base there?
10.
10. What's my exponent?
1.
X.
X. And the thing that ends up by itself?
1.
The argument. So now, what power can you raise something to turn it into 1?
0.
0. Anything to the 0 power is 1. And that's what this is saying. How about log base 5 of 1? That's saying 5 to what power would give you 1?
Would it be 0?
You'd have to raise it to the 0 power. Yep. Any question on that fourth property? Let's try a few more of those. See if we can figure out.
Oh,
I can erase the examples I had.
Dude, did you hear that guy at lunch that was like, yeah, that guy was so
So first thing is look at the property and see if you can figure out which one it matches. This is the same thing we just did. We're just doing more. Is it property 1, 2, 3, or 4?
1.
That is property 1. Yep.
So would it be pi?
So yeah, the answer here when we simplify everything would be pi. Because the bases are the same, they cancel out, and you're left with that right there. That's property 1. How about that one? What property is that for?
It's
It equals
Two.
-4.
That's property 2.
and the thing is -4.
So that A's cancel out, and the answer is whatever I'm pointing to with that arrow right there. So yes, that one would be -4. How about log base 12 of 12?
1.
That's property
Three.
3. So that's a 1. We'll do one more. How about log
I'm guessing the answer is 0.
base 5 of 5? 1. Change it because you said that. So yeah, that would be 1. And then how about log base 6 of 1?
0. 0.
That's property 4.
You just have to make it a street good.
Okay, so just looking at the problem and then matching up exactly what you have with one of those 4 things. Any question before we do the last thing?
No.
Okay.
Oh, yes. I'm just getting at it. I was just.
No. All right. So the last thing. Let's say we had log of 3 times 6. What is 3 times 6?
18.
18. Okay. That, and you wouldn't know unless I showed you, turns into that.
What?
Let's see what happens. Let's try it. Put that in the calculator. Log of 3 times 6, or you could do 18. Okay, we get that. Now let's try log 3 plus log 6. Did I get the same thing?
Yeah.
Yeah, I got the same thing. What is another way, besides 3 times 6, that you can get 18?
4 times 3. 8 plus 10.
What is it?
2 times 9.
2 times 9. Let's try that and see what happens. Log 2 plus log 9.
Crazy traps.
Same thing again.
The same thing.
So when I had that, what happened when I turned it into a different parenthesis? I mean, what happened when I got rid of the parentheses and wrote it like on the right?
Nothing. Did the same thing.
Well, it turned into something. This multiplication symbol went away. What did it turn into? It turned into addition. So whenever you have a problem that has multiplication, you can turn it into a problem with addition. So multiplication turns into addition. Notice the base we started with was what? A. And what about the base when we turned it into addition?
A.
A. The base doesn't change. Whatever you start with here, you use exactly the same thing there and there. This is the first thing you were multiplying. This is the second thing. There's another example with numbers. So instead of writing 4 times 5, we can write it as log 4 plus log 5.
Bless you.
Bless you. All right, so that was multiplication. What do you think would happen if this was division?
Would it become subtraction?
That would become a subtraction. Yep. So if you have a log and you are dividing 2 things, you can turn division into subtraction. This is the numerator. This is the denominator. Does it matter when you subtract about order?
No.
So like 5 minus 3, 3 minus 5?
Yes, it does.
Yeah. With addition, it doesn't, but with subtraction, it does. The top goes first. The bottom has to be second. So I'm not going to type it in, but you tell me. When I change that so I don't have this fraction anymore,
You'd subtract the 2. So
Yeah,
it'd be
well-
log A4 minus log A5.
yeah. And A is just whatever base the problem started out as. Just copy the number they use. Or if they use a letter, copy the letter. Any question on that? All right, so last property. And then we'll just try some examples. Okay. What's happening in that one?
It's changing from an exponential form to log form.
Something is changing, something's moving.
The R.
Yeah, where's the R going?
Away.
It's going to the front. So anytime that you have an exponent and it is on an argument in a log, you can put the exponent in front, just like that.
How would you do that?
Why would you do it?
Yeah.
Because if the exponent is a variable, variables are complicated when they're exponents. If we can get them to not be exponents, it gets easier.
But if you have like your example, it just says 5, so could you just make it like?
Yeah, this is just an example with all numbers. That's just arithmetic. There's no algebra there.
Okay.
But if there was algebra involved, it's always easier to have to not have an exponent than to have one.
Okay.
Yeah.
So you said we have a test on this tomorrow?
Yep.
Yeah. Yeah, it'll be a take home.
Have you done this take-home quiz before?
Honestly, I don't remember if I have. Maybe, it depends on when the week falls. It's different every year. Yeah. And we're at a little bit different point. So,
A big
You
different
phrase
point.
things so kindly.
We're a little special, Wyatt.
all right, so let's try this one. So this is basically saying to take that and separate it.
Would you add the 2?
Well, that's what we have to decide. It's either it splits into addition or subtraction.
It's addition because you're multiplying.
Right. There's 3 times x inside the parentheses. So it's going to be an addition problem when we're done. We're going to have 2 logs. What is the base on each one of them?
4.
It stays exactly the same as the original. 4 and 4. What is going to be the argument to my
3.
first log?
Plus 3.
And the argument to my second. That's how you take a log and split it into 2. This second sentence didn't come into play. Okay, there were no exponents to worry about. I'll do one next that has exponents.
Can you keep that? Yeah, keep that.
So what that second sentence means is do not leave exponents in the final answer. Put exponents in front. That's how you say that. Make powers into factors. All right, so let's look at this one. If you kind of get stuck with it, don't think about the whole problem at once. Just think about that and that. Okay. What operation are we doing?
We're adding.
Multiplication, so
We
you're
don't.
going to do adding.
Right. So don't even worry about what's under there yet. We're doing multiplication, so it's going to be adding.
Under where?
Well, under the black box. Yeah. What's going to be my log
2.
base? Yep. It's going to be a 2.
Oh,
It's
yeah.
going to be a 2. Now we have to look at the black box.
5.
My first argument is a 5.
Reading.
Bingo.
Bingo.
R.
And what's my second argument?
R to the
R.
third.
So it's r, and it would be to the third.
We don't want
But
an
you can't have
exponent.
exponents.
But where can we put the exponent?
In the front.
In the front. So it's not really a hard rule. It's just lots of little rules to remember.
Together.
But that's why you can, anytime you do a problem, just look in your notes for the rule.
That's a lot of work.
Yeah.
To look in your notes?
Yeah.
That's probably why I
You
failed.
subtract.
Okay, so let's look at this one. What's happening inside the parentheses?
We're dividing.
We're dividing. Dividing turns into what?
Subtraction.
I knew that. Subtraction.
So you're going to subtract 2 logs.
And the base would be 9.
The base is going to be a 9.
So it would be x minus 2.
And your first argument,
X.
X.
can it be either one?
No,
No,
it has to be x.
Has to be the top one first,
Yeah.
Then the bottom.
then the bottom one second. Yep.
How do you feel?
Will we ever get questions that's the bit out?
With what?
Does that answer your question, though?
Well, are you a little slow?
Okay, so what?
But there's an e in there. Oh, it's log e. No, guys. Yep.
So now we did it with base 9. We did it with base 2. We did it with base 4. That was going to be my question. What base are we using here? We're
E.
using E. We don't write base E. We're going to write it just the way they wrote it.
Ellen.
We're going to use the ln. So this is going to split into 2 ln's. But is it an addition or subtraction?
Subtraction.
It's subtraction because it's
Would it be
division.
3y?
Yeah.
3
No,
ln
it'd
y.
be 3, yeah.
3
So-
ln y.
Yep, so this would be a y to the 3rd,
But the 3
Put it
was
in the
the
front.
but they said to put the 3 in the front.
Mhm.
And what would you put here?
You'd put
Ellen.
in it.
8.
I don't like this game.
That's too dang bad.
All right, we'll try the game in reverse then. How do you like that?
No.
No.
Only for Will.
Yeah, Will. Just do it for Will.
Fighting words.
Everyone else doesn't need to do it.
I hope that's.
So now, we did it the harder way, which is taking something that's
Oh.
already combined and splitting it. Now this is the easier way.
So log
You're gonna put it
a parentheses
back
one
together.
times
Log A
3.
times 7 times.
3.
Log A 7 times 3.
So-
7 times 3 to the 4th.
Start with, the last thing you would have done is you would have put this number in front. So where would this number go back?
On top of 3.
Over 4.
It
On
would-
the fourth.
Somewhere.
It would go back as an exponent on the
3.
on the 3. Okay, let's just write that. Okay, so that's first step. Now, at this point, I would do 3 to the 4th out, so we don't have to keep that. We can figure what that is. What's 3 to the 4th power? 3 times 3, and then another 3 times 3 multiplied together. 81. Yep. On base A of 81. So now we're going to recombine those into a single log. What's going to be the base?
A.
It's going to be base A,
And we're adding.
7 times 81.
and we're adding, so what would it recombine
Multiplying.
as? Multiplying. And 7 times 81,
Oh, jeez.
Oh,
That's a big number.
That's a number, all right.
567. Okay. all right.
567.
567.
Did you know that answer? Or you just?
Yeah, in my head, I just did, in my head, I did
7 times
this.
8. Yeah, I got you. Plus 7.
I think of it as 560 plus 7, 567.
That's a lot
Right
of
at
work.
this game.
It's really.
Or just
My brain don't work.
use your calculator, that's okay too.
But you did it in your head.
I did,
But
yes.
he's also a lot smarter than us.
Says who?
All of our math tests.
This is more practice.
All right.
He has more experience.
Let's try, see if we can combine this.
What made you want to be a math teacher?
I
Math.
don't know, I'll tell you after, I'll tell you.
Okay.
We'll tell you later.
Okay, so it's ln minus another ln, and what's in front of the first ln?
LN.
2.
No, in front of it,
Oh, minus.
2/3.
I was looking at the other one.
You said the first one.
Oh,
Anytime you have a number in front, where does that number go back?
It goes to
Behind
the
it.
exponent.
Goes
no.
back as the exponent.
So, I am.
So it's ln of 8 to the what?
2/3.
Okay, I'm going to use my calculator to get that.
And then there's 10.
So now this is something we should do out, so we don't have to keep that. What's 8 to the 2/3?
Jesus.
What's 8 to the 2/3?
4.
Yes.
What?
I don't know what the
Likewise.
calculator said.
2 times 8 is 16 divided by
I
3
did not
squared.
get that.
Oh.
You didn't get it when you typed that in?
No, I was trying to figure that part, but no, I did not.
So yeah, 8 to the 2/3, it should come out to 4.
I got 4.
All right, so you
For you.
use your calculator, you get that.
Forecasting.
Now, when you recombine those, what's going to be our log? What's the base?
E.
E, it's not
Should be
written.
ln.
Yeah, just making sure people remember what that
4
means.
divided by 10. But it can't be 10 divided by 4 because it's subtraction. It can't do the opposite.
Yep, it's going to be 4 divided by 10.
There you go.
Okay, yes.
And what would that reduce to?
That was,
2/5.
yeah,
Yeah.
that number.
And we don't have to do that out. We just leave it as 2/5.
Can we stop here, please?
Yeah, I'm about to fall asleep.
Yeah, I think
I'm
that's.
about to have an aneurysm.
No, well,
Dude.
You literally had me this entire lesson. Please don't.
You're okay with it?
Yeah.
It seems okay?
Yeah.
it seems okay now.
It's not, like I said, it's not like one big, huge process. It's just 3 little things we did. So changing exponential to log form, the 4 properties, and then the last thing. So that's the 3 parts of today.
What's some homework?
You're not gonna hand it to me.
Yeah, I already
Have
know.
some patience.
Okay, so the homework, it is on 292. And again, make sure you look at this video because I changed a few things.
Oh, shit. Oh.
What is it? This is not the whole thing.
No, that's the whole thing. Some of it looks a little bold because I erased it and I just changed some questions. In fact, let me double check.
Hey guys.